Welcome to the first of 4 short videos on the subject of cable testing and diagnostics. So what is this all about? Over the course of 4 videos, we want to show how cable testing and diagnostics allow you to plan the maintenance of cable routes, thus preventing expensive power failures and significantly reducing maintenance costs for cable networks. We also list tried and tested measurement methods, describe these in detail, and introduce various options for their use. Finally, we provide guidance on the successful implementation of diagnostics. Every network operator understands the importance of cable networks. When planning the maintenance for these networks, distribution network operators have to manage the conflicting requirements of scarce resources, high standards in terms of security of supply, and the issue of networks that are becoming older and more complex. On the one hand, the budget available for maintenance is being steadily eroded, and on the other hand, lower grid charges caused by deregulation are leading to higher pressure on the cost side. Another issue is the reduction of personnel capacity. At the same time, customer expectations regarding network quality and security of supply are rising. This results in a demand for cable networks that are always intact and fault-free, and for failure prevention. Medium voltage networks are also becoming increasingly complex. This leads to cable routes that incorporate a wide range of cable types, joints, and terminations. It also leads to different degrees of aging depending on the cable segments in question. These conflicting requirements can be resolved using condition-based maintenance. The data for this is supplied by cable diagnostics. So what do we already know about cable diagnostics? There is a myth that cable diagnostics is expensive, complex, and not worthwhile, because only very few cable faults occur anyway. Let us take a closer look at these assertions. In what follows, we wish to further illustrate the benefits of cable diagnostics from a technical and financial point of view. Cable diagnostics is widely used in the acceptance testing of new cable routes. More and more power supply companies are replacing the simple voltage test with intelligent voltage testing called smart testing. This means that in the monitored withstand test, voltage testing and diagnostic measurement are performed at the same time. This saves time and supplies valuable information for asset management. This is because it gives users a very clear idea of the quality of the assembly work. Assembly errors are thus highlighted at an early stage and can be eliminated during the warranty period. During cable testing on worn cables, a distinction is made between a general condition evaluation of critical cables and the inspection of cables after repairs. The general inspection supplies information about the condition of the network status, which facilitates maintenance planning. Testing after repairs has 2 purposes. Firstly, to check the assembly quality, and secondly, for condition detection and to check whether the problem has been rectified. This allows claims to be asserted during the warranty period, the quality of the cable route to be improved, and consequential costs to be avoided. In the next section, we will compare the investment costs with the benefits of diagnostics in numerical terms. When considering this subject from a financial perspective, the following investment costs should be planned over a 10-year period. Staff are required for cable testing and diagnostics. Initially, costs start at around €50,000 per year. Then the costs of training and investment in building staff experience must be added to this. The costs for staff and expertise add up to around €54,000 per year. In addition, expenditure between €9,000 and €30,000 per year must be allowed for to cover the required equipment, which gives rise to a total budget for testing and diagnostics of €63,000 to €84,000 per year. This represents costs of €250 to €840 per cable route, depending on the number of measurements conducted. This compares to the following savings that can be achieved by the use of cable testing and diagnostics. Failures after the expiry of the warranty period can be significantly reduced by the checking of assembly quality, resulting in savings of at least 2,000 to 5,000 euros per component. Condition-based maintenance makes it possible to strategically replace components before they fail. This gives a saving of at least 2,000 to 5,000 euros per component. Evaluating the condition of cable routes makes it possible to strategically plan for maintenance projects. For example, if a weak spot is detected, the repair can be scheduled for the next time excavation is necessary in this area. If this is not discovered in time and subsequently leads to a fault, an additional excavation must be commissioned, which can be complex and expensive, especially in an urban area. The savings in such a case are at least 10,000 euros. Diagnostics also help when worn cable routes are being replaced. Once cables have reached a certain age, they are often replaced on a precautionary basis to prevent failures. In this situation, diagnostics can be used for condition evaluation, which can extend the service life of a cable if it turns out that the cable is still in good condition. Here is an example. Let's assume the costs for the laying of a new cable route are 300,000 euros, and the normal service life of a cable is 40 years. With the aid of diagnostic measurements, it is now possible to establish that the cable is still in very good condition and can therefore remain in place within the network for another 10 years. Consequently, this measurement extends the service life of the cable route by 25%. If this is the case for several cable routes, savings of over 100,000 euros per year are possible. Furthermore, sections of the cable route can be replaced instead of replacing the entire route. This has proved its value several times. For example, for a user of Power VLF True Sinus technology. Instead of replacing the entire cable with a length of nearly 2,000 meters, it was possible to replace a section of just 618 meters, thereby saving nearly 132,000 euros. If we now compare the required investment costs with the benefits, we see the return on investment attained by testing and diagnostics. It is clear that the potential savings are not, as originally assumed, restricted to the elimination of cable faults. There are also enormous savings to be made by extending the service life of cables and by replacing segments rather than the entire routes. With that, we can refute the myth that cable diagnostics is expensive and not worthwhile. In the next video, we will show the standards and principles for diagnostics and measurement methods, take a look at the application, and investigate the myth of complexity.
Power, ensuring the flow.